that machine. Let me quickly run down the question. Okay, so solution. As I'm reading the question, I'll be bringing out the parameters involved in the question. The efficiency of a machine is 80%. That's efficiency is given as 80%. 80%. Okay. So determine the work done by the student. The work done by the student is the same thing as work input. Okay. So my work input is unknown. That is what we are looking for. My work input is the same thing as my what? Work done by the student. Okay, let's proceed. Using this machine to raise load of 200 kilogram. That's my mass is given. My mass is given as what? 200 kg. That's kilogram. Okay, through a vertical distance. My distance is also given. Vertical distance of 3 meters. My distance is 3 meters. Okay, let's now say take G. My gravity is given as well. Take G to be equals to 10 meters per second square. Let me use this one. 10 meters per second square. Okay, the next thing I need to do is to bring out the mathematical expression for efficiency. So my efficiency is equals to my work output divide by my work input okay, divide by my work input, okay, multiply by 100%. Multiply by what? 100%. Okay, this is my mathematical expression for efficiency. The next thing I need to do is to look for my work output. Okay, that's the reason why the mass is given, the gravity is given, and the distance is also given. So on my work output, I have my load, because my work output is equals to my load times my distance moved by the load, which is small l, times my distance moved by the load, which is small l. Okay, so I need to look for my load as well. My load is the same thing as mg. Okay, so my load is equals to, anyway, I see my mass is given. Okay, my mass is given as 200 times my gravity is 10. 200 times 10, what will I get? I'll have 2000 what? Newton. 2000 Newton. So I'm done looking for my what? For my load. So I'll now come back to my work output. So my work output now will be equals to, anyway I see my load, I'll put my 2000, which is 2000 times what? The distance moved by the load, which is 3. Okay, what will I get? Which is equals to 6000. So I have my 6000 what? Joule. So I'm done looking for my work output. I'll now go back to my mathematical expression for efficiency. So my efficiency is given as 80%. So anyway I see my efficiency, I'll put 80%. That means 80 divided by 100. Okay, is equals to, anyway I see my work output. My work output is 6000, which is 6000. Okay, divide by my work input, which is the work done by student. Work done by what? Student. Okay, work done by student times 100 divided by what? 100. Okay, let's proceed. All right, The next thing I need to do is that 80 divided by 100, I have 0.8. 0.8 is equals to 6,000. 6,000, okay, divide by work done by students, same thing as my work input, work done by students, okay. My 100 divided by 100 will be 1, so it will cancel out, okay. So the next thing I need to do is to cross multiply. What will I do? When I cross multiply, what will I get? So I'll have my what? Work done by students times 0.8. Work done by students. Work done by students times 0.8. Okay. Work done by student times 0.8 is equals to 6,000. Okay, so remember what I'm looking for is work done by students. So I'll divide both sides by coefficient of work done by students. So my work done by students, is equals to my 6,000 divided by 0.8. okay, so my work done by students is equals to 6,000 divided by 0.8. I'll have 7,500 what? Joules. So this is what we are looking for.